Hello everyone, welcome to the channel. In this video, we will see a problem on Newton's second law or D'Alembert's principle. So the problem states that a horizontal force P equal to 600 Newton is exerted on block A of mass 120 kg as shown in the figure. The coefficient of friction between block A and the horizontal plane is 0.25. Block B has a mass of 30 kg and the coefficient of friction between it and the plane is 0.4. The wire between the two blocks makes 30° with horizontal. Calculate the tension in the wire. Okay. So in this problem, let's see what are the given data. So given data are, they are given a force. They are given a force P equal to 600 Newton. So if you see the diagram, the 600 Newton is applied on the block A. Okay. And block A mass is equal to 120 kg and block B equal to 30 kg. Okay. Here in this problem, they have given the coefficient of friction for both the blocks, that is mu A equal to 0.25 and mu B equal to 0.4. So they have given different mu for both the blocks. And additionally, they said that both the blocks are connected by a wire, but the wire is in 30° with the horizontal. You can see on the diagram. Okay. So what are we supposed to find? To find tension in the rope. So find tension in the rope, tension in the wire, that is T, and in the wire T. Okay. So how can we solve? Again, we'll be using Newton's second law of motion to find out this tension in the wire. Okay, so before diving into the solution, let's have a common thing that when we apply a force in this direction, and what will happen is the direction of the block will be from left to right. Okay, and it will move in left to right direction. Similarly, the B block will also move in from left to right direction because both the blocks are connected by a wire. Okay, now this angle is making 30° with the horizontal. Similarly, if you see, the A angle is also making in 30°. That is an opposite and alternate angle. Okay, so here also is 30°. So now what we can do is we can draw the FBD for the block A. So FBD for block A. By looking at the diagram, so we can say that this is our block A. It is resting on the horizontal surface. So we have a force is applied from left to right, P, which is equal to 600 Newton, and we'll have a weight of the block as well, which is acting downward, that is W equal to 120 kg. So we have to convert into Newton. That will be 120 into 9.81 Newton, and we'll have a normal reaction as well, normal reaction N. Since the block is moving from left to right, so here we'll have a opposite direction will have a frictional force, that is mu A and Na. Okay, so here also I'm writing down Na, so that we'll have a different for blocks. So A block, and right, so that is one more thing. We'll have a this also a rope, a wire is acting, that is a tension T. This is making an angle with 30°. Okay, so we know that whenever we have an inclined force, we have to resolve this force. So if we resolve, we have two components. One is the cos component in this horizontal direction, that is t cos theta, and one is vertical direction, that is t sin theta, sin 30. So the component also resolved. T is resolved into two components. One is cos theta and sin theta. Okay, so now we are completed with the FBD. First of all, we want to apply Newton's second law. By Newton's second law, of motion, by Newton's second law of motion, summation of f of x equal to m into ax. Okay, so here fx is nothing but all the horizontal force. If you see, we have a force p. Okay, so the direction of the block will be from left to right. This will be a direction of the block is from left to right. Okay, so here p is plus p, positive, and minus mu a into na. And what else? Yeah, we have this also, that is t cos 30, which is also opposite towards the direction, so minus t cos 30. So this will be equal to, mass is 120 kg, and this will be ax. Okay, now we'll try to apply all the values. So p is 600. So what is the value of mu a? Mu a is 0.25. We don't know na, normal we don't know. So minus of cos 60 would be 0.88, I guess. So put in the calculator, cos 30 will be equal to it's 0.866t. This will be equal to 120 ax. So I'll make this as first equation. Okay. Now summation of f of y will be equal to m a y. So here all the vertical forces. So if you see, we have one vertical force, that is weight is acting downward, W. Then we have a normal which is acting upward, that is Na. Then we have a again minus of t sin 30 is acting downward, the component of tension. This will be equal to mass of the block, that is 120 kg, and Ay will be 0. Because why Ay will become 0? The block is not moving in vertical direction. Okay, the block is not moving in vertical direction. That is the reason we're taking in 0. Okay, so Ay will become, therefore Ay will become 0. This is the main reason, because the block is moving in horizontal direction. Okay, so from here what we can do is we can find out the value of Na. So Na normal A will be equal to, so if you take a minus 2 to that side, it will become positive, W also positive, that is 120 into 9.81 plus T of sin 30. Okay, so I'll put in the calculator, 120 into 9.81. I got the value as 1177.2 plus sin 30 is half, that is 0.5. So 0.5 t. This is the value of Na. So substitute the value of Na. Substitute the value of Na in first equation. Substitute the value of Na, normal reaction of block A, in first equation. So we'll get 600 minus 0.25 into 1177.2 plus 0.5 t minus 0.8660. This is equal to 120 A. Okay. So let's multiply the values. 0.25 into 1177.2. I got value as 290. That is 600 minus 294.3, because this 0.25 will be multiplied inside. Okay, so minus 0.25 into 0.5. I've got minus of 0.125t, then minus of 0.866t. This is equal to 120a. So here if you see 600 minus 294.3, it is equal to some 305.7, and minus 0.125 minus 0.866, it's minus 0.991t. This is equal to 120a. So we can take that t to that side and rearrange the term. That is 0.991t plus 120a will be equal to 305.7. This is your second equation. Okay. Now similarly, we have to solve for FBD for block B. Okay, if you look at the diagram, so block B as it is resting on the horizontal surface, and the rope is having that wire of the tension will be having 30 degree. Okay, so we'll draw the FBD for the block B as well. So here block B, so here we'll have a weight that is 30 kg, weight equal to 30 kg. You can multiply it by 9.81 to get it in Newton, 9.81, and again the tension is like this. Tension of the wire is having 30 degree T. Now this can be resolved into two components. One is cos component, T cos theta, and T sin theta, sin 30. Then afterward we have a normal reaction as well, NB, and since the direction is towards this side, because block A is also moving from left to right, so block B will also moving left to right. So if the direction that way, so here you will have a mu B and NB. This is frictional force. So these are the force acting on the block B. So now by Newton's second law of motion, summation f of x equal to m into ax. So here in x direction we have t cos 30, which is in the same direction of the block. This will be positive, and mu b dot nb will be negative. This will be equal to mass is 30 kg into ax. Okay, so cos 30 is again 0.866t minus mu is 0.4. We don't know nb. This is equal to 30 ax. So this can be taken as third equation. So now by summation f of y is equal to m into ay. So vertical forces, that is weight is acting downward. So weight is acting downward minus w, then plus nb. Then again we have a sin theta as well. So plus t sin 30. This will be equal to mass is 30, and again this will become 0 because AY direction will become 0. AY will become 0. Okay, so now we have to go for NB. So NB will be equal to, we can take all the other terms. So minus W will become 30 into 9.81 minus of T sine 30. So if you do the calculation, 30 into 9.81, this gives me 294.3, 94.3 minus sine 30 is 0.5 T. This is the value of NB. So you can substitute the value of NB in third equation. Substitute the value of NB in third equation. So we get 0.66, sorry, 0.866 T minus 0.4 into 294.3 minus 0.5 T will be equal to 30 into A. So here you have to multiply these values. 0.4 into 294.3, this gives me again 0.668. This is minus 117.72 minus plus. So 0.4 into 0.5 gives 0.2 T. This will be equal to 30A. If you see, so we can add both the T's. So we can have this and this T. 0.866 plus 0.2. It gets 1.066 T minus of 30A. I have taken this A to the equal side. This will be equal to 117.72. So this is your fourth equation. Okay, so now solving second and fourth equation. Solving second and fourth equation simultaneously. We get so tension will be equal to 147.78 Newton and A will be equal to 1.327 meter per second square. So these are the two values required. Okay, so from the given problem, we have to only find out the tension in the wire. We found out the tension in the wire, that is 147.78. I hope you understood this problem. If you have any doubt, you can post it in the comment section. Thank you so much.